A very good morning to everyone. I am Swayam Prakash Tiwari, leader of team Adviti, and today I am here to propose a solution on the problem statement that says temple and pilgrimage crowd management system for Somnath, Dwarka, Pavagadh, and Ambaji. The problem statement ID is 25165 and my team name is Adviti, which is registered under ID 78242. My idea title is DevPath, AI driven pilgrimage flow control and autonomous crowd flow management system. The solution explains first overcrowding. As a client, you have to scan a QR code and enter your unique name. You will be directed towards a map where you will be shown in marker. This will be just the client's part. The server gets real-time location of every client in form of GUI on map. If any person does not follow the predefined route, the server can also text him. This can be explained as if this is a temple and it has three routes, and if a person comes here, parks his vehicles, he has to scan a scanner, a QR code. After scanning the QR code, he is directed to one of the routes that leads towards temple. Now, as he scans it, he has to enter his unique name. After entering the name, he will be assigned a route that he has to follow. His color of the marker will be based on the category he chooses. If it's woman, it would be red. If men, blue. Kid, green. And differently abled, it will be grey. So you will be individually shown with the marker color that you choose here. So this map will drop you to the nearest location of the Garbhagri. You will be shown waiting time, puja time and aarti time here on the map. So this was all what a client does. Now a server can collectively see people. On the map, you will be shown individually to you, but the server can see you collectively and he can text you. If you don't follow the route, your marker will be marked black. Tapping on the marker would give your name and your ID. If the server taps it, he will be able to send you message and ask you the reason and to get into the line back. So this was all. We are thinking to assign police force and medical staff depending upon the upsurge of any of the routes. So if I talk about IoT and surveillance system, our system reduces the use of IoTs and still omit out the perfect data. My uniqueness is this problem never existed in any of the temples. We are the first one to do this, and no system gives local bus assist to pilgrimage sites. Yes, we are doing it. We are giving you local bus assist to these sites. My innovation is personal map based tracking with autonomous authority decision making system with guide to take decision of planting force and systems based on upsurge. As I told you, we will be giving people routes. Like if three people are there, we will be giving them three different routes. But what if a family comes? We will assign them one route. In this way, if any of the routes get upsurged in number of people, we will be assigning them force and medical staff on the basis of that. And this all work will be AI driven, like no human intervention, just a person has to guide it. New routes and connectivity will be open in case of trampades or in case of any crowd unmanagement happens. If there is a stampede or there is any issue, new routes will be shown to individual different routes for people to evacuate so that there would be less condition for a stampede to increase. We will be giving connectivity to the people. We will be giving camera surveillance. If a person does not have phone, he will be scanning the camera, and every camera on the route towards temple will be updating his location. In this way, we will be having everyone's data in our database. We will be also updating the data of the person who are on the map. The map data and the camera data both will be combined to give a output. So, if there is a condition of stampede or emergency, new routes will be visible, and that will be done by authority permission. Force and medical staff will be assigned relatively. The technical approach, if I talk about, I have used Python for maps OSM, CV2 for camera surveillance, Wi-Fi. I have also used CSS, HTML and JavaScript. We have used API for the bus services. We use the QR ticketing method. So our methodology is as explained. The client enters the destination, gets a route, time of darshan and travel services and online ticketing system. As he enters the temple premises, an image is saved at camera at the entry locations. User all pilgrims scan a QR and gets a map opened on their phone showing them their personal way to Garbhagriha. Timing of the darshan and wait times are shown relatively on the maps. They can receive all messages sent by the server, and the server can see people in form of icon. If decided route is not followed by the client, the server can send them direct message and notifications on their phone. So the implementation is mapping the routes of temple, giving camera Wi-Fi, and this is solved by the government. The government is planning about 800 cameras with Wi-Fi on the routes, and this will be helpful to us distinguishing between pilgrims and locals. Yes, if office going locals follow the same route, we will be giving them a different route as to the differently abled person. Differently abled will be given new routes and new methods to reach the temple, which are explained in the PPT as well. The feasibility of our application is good. As technical feasibility, we are having QR, server client combination, and GPS tracking. These systems are available. We use Flask, Leaflet, or OSM and Socket IO. These all are open source tool, free and does not require any money. Our operational feasibility is too high, as pilgrims just has to scan a QR code and he can get his tickets on phone. So everyone will be carrying the phone. The problem of not having the phone is resolved here. No advanced training is required.